Okay, Chapter 10, we're dealing with ratio and proportions. After you read through this chapter and then watch the examples I'm going to give you, your learning objectives should be, after completing this chapter, the student will be able to define the terms of ratio, proportion, and dimensional analysis, explain how to solve problems using ratio and proportions, explain how to solve problems using dimensional analysis, demonstrate how to solve common pharmacy problems using ratio, proportion, and dimensional analysis. Okay, a few things to look at first is ratios. So ratios are going to be used to make comparisons between two things. When you express ratios in words, you use the word to. For example, you say the ratio of something to something else. So a ratio can be written in several different ways. It can be written as a fraction, which you have here, and then I turn on and put the fraction upward as well too. You can use it as the word to, so 3 to 5, or you can use a colon, so 3 colon 5. 3 means 3 to 5. Okay, so when you're solving problems using ratio and proportions, you should remember that the product of the means is equal to the product of the extremes. So a proportion is a name given to a statement that two ratios are equal. Proportions, of course, can be written in two ways, such as a fraction, A to B equals C to D, or using a colon, A dot dot B equals C dot dot D. That's what I used here. But if you notice here, the means, B equals C, and then you have the extremes, which is A equals D. And this is what they are here. So A over B equals C over D. Okay. So once you do a ratio proportion and you solve it, say what you're going to do, they're going to give you three parts that's known and one part that is not known. Once you find that part that is unknown, you'll have your four parts. So then you could always check your answers. So I kind of tell people, so your means should always equal your extremes. And for example, we'll give you here on page 75, question number 2. You have 2 over 3 and 4 over blank. So this is what I call your x. So what I tell people to do is I always put mine upwards like this. 2 to 3, and is always going to be an equal 4 over x. So how I tell people, this one you could actually figure it out if you wanted to, but your numbers are going to get larger, so I always show people this ratio proportion way, the cross multiplying. So whatever you're trying to find is x. So 2 times x is x. That number always goes on the bottom, 2x. So the x can be anywhere, and as whatever multiply the number of the x by, just remember it always goes on the bottom. 4 times 3 is 12. Okay, then you divide 2 divided into 12, of course, is 6. So your answer up here would be 6. So then what you could do to figure out, do I have this answer done correctly, is 4 times 3 is 12, and 2 times 6 is 12. So the extremes and the means equal the same. Here's another example, number 4. 3 over 6 equals 1 over x. Okay, again, whatever you multiply the x by, it goes on the bottom, 3x. 6 times 1 is 6. So you have 6 divided by 3 is equal to. So you have a 2 here. So 6 times 1 is 6. 3 times 2 is 6. So you have that is correct. Okay, now on number 8, we have our x over here. So x over 8 equals 3 over 24. Again, whatever you multiply the x by, it goes on the bottom. So 24 times x would be 24x. 8 times 3 is 24. So 24 divided by 24 is 1. So to double check yourself, you can put a 1 here. And 8 times 3 is 24. And 24 times 1 is 24. So that's just a way that you can check your answer to see if you're correct. Number 16, 3 over 5 equals, or is 2x over 100. So you multiply whatever you multiply. Remember, it doesn't matter where they're x at, as long as when you multiply that number by the x, it always goes on the bottom. So 5 times x would be 5x. 3 times 100 would be 300. And then you're going to take 300 divided by 5, and your answer is going to be 60. Okay, now the other questions in this chapter um, are quite easy. We actually did these last semester when I said, when we did that paper, it said, day supply or the metric quantity. Okay. All of these written questions in this chapter are pretty much, they're saying you could figure them out by dimensional analysis, but this was just figuring out pretty much the quantity. So if you look at number 34, it says how many tablets are needed to fill a prescription. So that's how many, what quantity do you need, okay, for 34 days. And that tells you the name of the medicine, a Carbos 50 milligram tablet. One tablet 3 times a day is how they're going to be taking it, okay. So remember, one tablet times 3 times a day, and they did take it for 24 days. So you just multiply across. So 1 times 3 is 3, 3 times 34 would be 102. So they're going to need 102 tablets to fill that prescription. Okay, next we're going to do number 35, since it's right below it. How many capsules are needed to fill a prescription for 34 days for prednisone 1 milligram capsules, 2 capsules 3 times a day? So you figure out how many times we're going to take a day and then multiply it by the total days. So it'd be 2 capsules 3 times a day, and they're going to take it for 34 days. So 2 times 3 is 6. 6 times 34 is 204. So they need 204 tablets or capsules. Number 37. Again, how many capsules are needed to fill a prescription for 34 days for potassium chloride, 10 milliequivalent per 1 capsule 4 times a day. So again, you're just looking at how much they're going to take per day and times it by the total days. So you have 1 capsule that they're taking it. They're taking it 4 times a day, and they're taking it for 34 days. So 34 times 4 times 1 is 136. Okay. And all these written questions are the same format there. Okay, if you go through this chapter and do some of the practice exercises out of Chapter 10, if you have any questions, please let me know. I'll be glad to help you during my office hours or during my open lab time. Just make sure that you email me and we can make an appointment.